Find the derivative of the following function. Or find the y, the x of the following each functions. X to the power of 3, x to the power of 5, x to the power of 1 over 2, 1 over x squared, 1 over square root of x, 1 over x to the power of 2 over 3, 3x to the power of 4 minus 2x to the power of 3 plus 7. Exponential x cos x, x square exponential 3x, exponential x square plus 1, 2x square sine x, x to the power of 5 exponential x, ln x, ln 3x square plus x ln x square plus 1, ln sine x, 1 over x to the power of 4 plus 1, 1 over 2 cos x, square root of 4x square minus 3, 3x square minus 4 to the power of 4, sine 3x, exponential x over ln x. To find the y, the x of each of the following without using first principle, let y equals to 5 or f of x equals to 5. F prime of x is the same thing as the y, the x. This is a constant function. Every constant function has derivative to be 0 by first principle. Derivative of the function is equals to 0. Why? Because it is a constant function. Every constant function has derivative 0. Is always 0 because the graph of every constant function is horizontal. The slope is always equals to 0. Number 2 is also a constant function. The derivative is going to be 0. But number 3, let y equals to x to the power of 3. This is a polynomial function of degree 3. Every polynomial function apply power rule. The power rule says that if y is of the form x to the power of n, then the y, the x, apply the power rule. The y, the x is equals to multiply for all n in real number. N x to the power of n minus 1. This is the same thing as n x to the power of reduce the power by 1. So y equals to x to the power of 3 is of the form this. The y, the x of this function is multiply the power with the function 3x and reduce the power by 1. Let y equals to x to the power of 5. This is a polynomial of degree. The y, the x of this function is 5x to the power of 4. Given the function, let y equals to square root of x. This is the same thing as the x to the power of 1 over 2. This function is called function to the power of radical. So to find the y, the x of this function, apply the power rule since n is coming from real number. In this case, n is equals to 1 over 2, which is in real number. Apply the power rule, multiply the function with the power, reduce the power by 1. So the y, the x of this function is x to the power of minus 1 over 2. This is the same thing as 1 over 2 multiplied by anything minus is same thing as 1 over x to the power of 1 over 2, the negative way. This is the reciprocal. This is the same thing as 1 over 2 square root of x. So the y, the x of this function is 1 over 2 square root of x. Number 6. Let y equals to 1 over x squared. The y, the x, same thing as x to the power of minus 2. So in this case, n is equals to minus 2, which is in real number. Apply the power rule. X to the power of minus 2, multiply it by minus 2, then reduce the power with minus 1. This is the same thing as minus 2, x to the power of minus 3. Minus 2 multiplied by 1 over x to the power of 3. This is minus 2 over x to the power of 3. X must not equals to 0. So the y, the x of this function is equals to minus 2 over x to the power of 3. Number 7. Let y or f of x equals to 1 over square root of x. This is the same thing as 1 over x to the power of 1 over 2. This is the same thing as x to the power of minus 1 over 2. So the y, the x of this function is n is equals to minus 1 over 2, which is in real number. Minus 1 over 2, x to the power of minus 1 over 2 minus 1. Minus 1 over 2, x to the power of minus 3 over 2. This is the same thing as minus 1 over 2 multiplied by 1 over x to the power of 3 over 2. Minus 1 over 2 x to the power of 3 over 2. Minus 1 over 2 square root of x to the power of 3. So the y, the x of the function is equals to minus 1 over 2 square root of x to the power of 3. Number 8. Let y equals to 1 over x to the power of 2 over 3. This is the same thing as x to the power of minus 2 over 3. The y, the x of this function is multiply by the power, then reduce the power by 1. Minus 2 over 3 x to the power of minus 5 over 3. This is the same thing as minus 2 over 3 multiplied by 1 over x to the power of 5 over 3. This is the same thing as minus 2 over 3 cube root of x to the power. The derivative of the function is minus 2 over 3 cube root of x to the power of 5. Let y equals to exponential x cos x. This is a product of exponential function and trigonometric function. In this case, I'm going to use the product rule technique to find the derivative of this function. By product rule, if y is given to be u of x, v of x, for which u of x in this case is exponential x, and the v of x in this case is cos x, then the y, the x by product rule is keep the first function, differentiate the second function, plus keep the second function and differentiate the first function. So the y dx now is keep the first function, differentiate the second function, plus keep the second function, differentiate the first function. So what is the derivative of cos x is minus sine x plus cos x. What is derivative of exponential? X by first principle is the exponential x. Then rewrite this function as exponential x cos x, exponential x sine x. Exponential x is common, cos x minus sine x. So this is the y dx of the function. Let y equals to x square exponential 3x. This is the product of two functions, exponential function and polynomial function. So you are going to use the product rule to find the derivative. Keep the first function, multiply by the derivative of the second function, plus keep the second function, multiply by the derivative of the. This is x square exponential 3x multiplied by 3 plus exponential 3x multiplied by 2x. 3x square exponential 2x exponential 3x. So the y dx of the function is 3x square exponential 3x plus 2x exponential 3x. It can be further simplified exponential 3x into 3x square plus 2x. Let y equals to exponential x square plus 1 power of polynomial. This is called because exponential u is a function on its own, where the u now is a polynomial of x square plus 1. Is called function of a function or composite function. In this case, the y dx is going to be exponential x square plus 1 multiplied by the derivative of the power, or the same thing as called chain rule technique. This is equals to 2x exponential x square plus 1. In other case, you can say let u of x equals to x square plus 1 and what? Let u equals to exponential u. So by chain rule, the y dx of the function is going to be g prime of plug in u of x multiplied by the derivative of u. Exponential u. Exponential u is still exponential u as derivative. What is 2x? The derivative of 1 is u. So what is u? Exponential x squared plus 1 multiplied by 2x. So the derivative of the function is 2x exponential x squared plus 1. Let y equals to 2x squared sine x. In this case, this is a product of polynomial function and trigonometric function. So in this case, you are going to apply the product rule technique. The y dx is keep the first function multiply by the derivative of the second plus keep the second function multiply by the derivative of the first function. This is 2x squared. What is derivative of sine is cos plus sine x. The derivative of 2x squared is 4x. Rearrange, this is the same thing as 4x sine x plus 2x squared cos x. So the derivative of the function using the product rule is 4x sine x plus 2x. Let y equals to x to the power of 5 exponential x. In this case, this is a product of polynomial function of degree 5 and an exponential function. Apply the product rule technique. So the y dx of the function is keep the first function differentiate the second function plus keep the second function multiply by the derivative of the second function. This is same thing as x to the power of 5. Derivative of exponential x is exponential x multiplied by exponential x. The derivative of this polynomial is 5x to the power of 4. Rearrange, this is 5x to the power of 4 exponential x plus x to the power of 5 exponential x. Exponential x is common. This is the same thing as 5x to the power of 4 plus x to the power of 5. So the derivative of this function is exponential x, 5x to the power of 4 plus. Let y equals to ln x. Ln x is the same thing as what? Log of x to base e. So what is going to be the derivative of this function is 1 over x, because by first principle, find the derivative of ln x, it was 1 over x. X must be bigger than 0. Let y equals to ln 3x squared plus 1. This is function inside another function. 3x squared plus 1 is a polynomial function. Ln of anything here, let's say u, is a function on its own, where u is equals to u depend on x is equals to 3x squared plus 1. This is called function of what? Function, or the same thing as composite function. For any composite function, you are going to use the chain rule to find the derivative. So by chain rule, that if the function is of the form g of u of x, then the derivative of the function is g prime of plug in u multiplied by the derivative of u, where u is a function 3x squared plus 1. So y is a function ln 3x squared plus 1. So the x of this function is g of u is equals to ln u of x is equals to 3x squared plus 1. So the derivative of differentiate the ln u, which is equals to 1 over u, multiplied by the derivative of u. The derivative of u is 6x plus 0. So this is equals to 1 over u. Plug in what is u. U is 3x squared plus 1 multiplied by 6x. So the derivative of this function is equals to 6x squared plus 1. Let y equals to x ln x squared plus 1. This is a product of polynomial and logarithm function. In this case, u of x is equals to x and v of x is equals to ln x squared plus 1, for which this is also a function of a function. So you are going to apply product rule first and the chain rule inside the product rule. So the x of this function, by product rule first, keep the function, then differentiate the second function, plus keep the second function and differentiate the first function. So in this case, x, what is going to be the differentiation of this by chain rule? By chain rule, say, what is this? 1 over x squared plus 1. That is the differentiation of ln multiplied by the derivative of the inside, 2x plus ln x squared plus 1 multiplied by the derivative of x, 2x squared over x squared plus 1 plus ln x squared plus 1. So the differentiation of the function is 2x squared over x squared plus 1 plus ln x squared plus 1. Let f of x, same thing as y, equals to ln of sine x. Of course, ln of u and another trigonometric function. This is function of a function. In this case, composite function, we are going to use the chain rule technique. So the y, the x of this function is of the form g prime u of x multiplied by the derivative of u, where g of u is equals to g of u is ln u and u is sine x. So the derivative of ln u is 1 over u, then the derivative of sine x is cos x. This is the same thing as 1 over plug in u. U is what? Sine x multiplied by cos x. This is the same thing as cos x over sine x cot x. So the y, the x is equals to cot x. Y equals to 1 over x to the power of 4 plus 1. This is a quotient for which the numerator is a constant function and the denominator is a polynomial. You can call it as what? U of x over v of x, for where u of x equals to 1 and v of x equals to x to the power of 4 plus 1. By quotient, this is a quotient of full function. By quotient rule is keep the denominator, differentiate the numerator, minus keep the numerator and differentiate the denominator, over square the denominator. So this is by what? Quotient rule. Quotient rule taking. So the y over the x of this function now, by quotient rule, keep the denominator, multiply by what? The derivative of the numerator, which is u, minus keep the numerator and differentiate. So by quotient rule, 4x to the power of 3 over x to the power of 4 plus 1 cube. So the y, the x of this function is minus 4x to the power of 3 over x to the power of 4 plus 1 to the power of 3. So by quotient rule, this is derivative of the function. Let y equals to square root of 4x squared minus 3. This is polynomial function inside square root function, composite function. The technique to use is chain rule. Let g of u equals to square root of u, for which u of x is equals to the polynomial inside the square root. So by chain rule, the y, the x is equals to differentiate u and plug in u of x back, multiply by differential of u. This is the same thing as what? What is the differential of what? G of u. This is u to the power of half. U to the power of half. 1 over 2 to the power of, reduce 1 over 2 by minus 1, minus 1 over 2. Multiply by, what is the differential of u of x? The differential of u of x is 8x minus 0. So this is going to be 1 over 2. What is u? U is 4x squared minus 3 to the power of minus 1 over 2 minus 1 over 2 times 8x. 8x over 2 into 4x squared minus 3. This is the same thing as 4x. 4x squared minus 3 minus 1 over 2. 4x over 4x squared minus 3 over 2, the reciprocal of this. It can be further written as 4x over square root of 4x squared minus 3. So this is the derivative of the function, the y, the x. So given the function, let y equals to 3x squared minus 4 to the power of 4. This is a polynomial function. Let g of u equals to u to the power of 4 and u of x is equals to the polynomial 3x squared minus 4. Function of a function, you're going to use chain rule. The y dx is equals to differentiate and plug in u of x multiplied by the derivative of u. This is going to be, what is g of u? G of u is u to the power of 4, 4 to the power of 3, multiplied by the derivative of u is 6x. The derivative of this is 0. So plug in what is u. U is 3x squared minus 4 to the power of 3 multiplied by 6x. This is the same thing as 24x 3x squared minus 4 to the power of 3. So by chain rule, the derivative of this function is 24x multiplied by 3x squared minus 4 to the power of 3. So let y equals to sine 3x. In this case, g of u is equals to sine u and u of x is equals to 3x. So this is a function of a function. To find the derivative of this function, I'm going to use the chain rule technique. Multiply by u prime of cos u. The derivative of sine u is cos u multiplied by 3, the derivative of 3x. Then plug in what is u. U is equals to 3x multiplied by 3. This is 3 cos 3x. So the derivative of this function is equals to 3 cos 3x. Let y equals to exponential x over ln x. So this is a quotient rule for which the numerator is called u of x exponential x and the denominator v of x is equals to ln of x. To find the derivative of this function using the quotient rule, keep the denominator v, differentiate the numerator, minus keep the numerator, differentiate the denominator, over square the denominator. So the derivative of this function is going to be, keep the numerator ln x dx of the numerator, minus keep the numerator, then differentiate the denominator, which is ln x, over the square of the numerator. This is the same thing as ln x. What is the derivative of exponential x? Is exponential x minus exponential s 1 over x, the derivative of this, over ln x all square. This is the same thing as ln x exponential x minus 1 over x exponential x over ln of x all square. Exponential x is common. Exponential x is common. Ln x minus 1 over x over ln x all square. So the derivative of this function is exponential x ln x minus 1 over x over ln x all square. Thanks for watching. That is all for this video. In the next video, we are going to find the derivative of implicit functions, log function, and other functions.